In this whiteboard technical video, we will discuss the fundamentals of a marine boiler used on ships. The main purpose of a marine boiler is to produce steam at high temperature and pressure. To produce steam, we require two basic components, water and heat source. When we supply correct quality and quantity of heat to water inside the boiler, it will boil at 100 degrees Celsius under atmospheric pressure. The boiling point of water is directly proportional to the surrounding pressure inside the boiler. To produce heat through fire inside the boiler, the three sides of a fire triangle must be sufficed. A fire triangle consists of oxygen, ignition source, and fuel. One more important factor involved in the fire triangle is the chemical reaction. When all the three sides of a fire triangle, that is oxygen, ignition source, and fuel, are in correct balance condition, chemical reaction occurs which creates fire. The fire generated in the boiler heats the boiler water in three ways or methods: radiation, convection, and conduction. Radiation. It is a heat transfer method which does not involve any physical contact between the heat source and the recipient for the heat to travel. Here, heat travels in the form of electromagnetic waves. For example, the sun, which emits rays that travels through atmosphere and heats up the earth, is a process of radiation. These electromagnetic waves does not require any physical medium to travel. The radiations from the sun heats up the earth and increases its temperature. Convection. This method of heat transfer mainly takes place in liquid or gaseous states. Because of heat supplied, the high temperature molecule will rise up and the cold temperature molecule will go down. The increase in temperature of the molecules leads to decrease in their density, which eventually rises them up. Let's take an example to understand this. Take a beaker or container and fill it with water. Now keep this container on a hot plate. As we all know, temperature is inversely proportional to the density. Because of the heat supplied, the molecules at the bottom part of the beaker will be at higher temperature. The rise in the temperature will decrease the density of these molecules and they will rise up, taking the place of cold molecules at the top. The cold molecules will then come down and get heated up from the hot plate. Conduction. In this method, heat is transferred between the two components only when there is a physical contact between them. Take a metallic rod and heat it at one end. The molecules of the metallic rod at this end will start vibrating due to increase in temperature and transfer the heat to adjacent molecules. These adjacent molecules will now start vibrating and they will transfer the heat energy to further adjacent molecules. This process continues until the heat reaches the other end. Now we will take these concepts and apply them in a practical way by building a marine boiler from scratch. The easiest method to produce steam is to keep water on a heat source. Let's take a container filled with water and open to the atmosphere. Keep this container on a high temperature flame. Water will start boiling and steam will be produced after some time. When we heat the water at 100 degrees Celsius with this arrangement, the steam produced is lost to the atmosphere as the container is open at the top. But if we collect the steam through a proper channel, then we can put it in some use. Let's cover the top part of the container and make an arrangement with an outlet pipe to collect the steam. If we continue heating the container, all the water inside will get converted into steam at some point of time, and eventually the container itself will get overheated and deformed. In order to overcome this situation, we need to supply an inlet connection to the container which maintains the water level and avoid overheating. Now in this arrangement, even if we have an outlet line to collect the steam, majority of the heat is lost to the atmosphere, whereas a part of it is transferred to the container through flames. To prevent this heat loss, we will put a frame around the arrangement. But putting a frame leads to another problem. It cuts off the oxygen to the flame. In absence of O2, which is one of the sides of the fire triangle, the flame will get extinguished in no time. To overcome this situation, we will need a forced supply connection such as a forced draft fan, which will continuously supply the right amount of air to sustain the flame inside the boiler. According to the theory of conduction we explained earlier, some amount of heat will be lost to the atmosphere due to conduction characteristics of the frame. First, the heat will be absorbed by the inner surface of the frame and then transferred to the atmosphere through outer surface of the frame. However, we can use this arrangement to make a proper working boiler. But it is also important to make this arrangement more efficient by introducing few modifications in the burner assembly, integration of heat resistant refractory in the furnace, and smoke tubes in the water drum to increase the heat exchange ability of the boiler, and an exhaust gas trunk to take out the exhaust smoke to the atmosphere. This is the general layout of a normal smoke tube boiler. Now let's understand how radiation, convection and conduction processes are involved in heating of water inside the boiler. The flame from the burner directly heats the water drum. The water molecules at the bottom part heats up and their density is reduced. This leads to heated molecules rising up and displacing the cold molecules to the bottom part. In this way, the water is heated due to convection effect. The hot electromagnetic waves from the burner travel forward in the furnace and heats up the drum by radiation process. The refractory helps in directing these electromagnetic waves and also contains the heat inside the furnace to avoid heat loss. The burner flame also produces hot combustion gases which travels inside the furnace and passes through the smoke tube. These hot gases heats up the boundary of the smoke tube and then the surrounding water by a process of conduction. These are the basic fundamentals on the basis of which a marine boiler is designed and operated. Thanks for watching this whiteboard video. If you want a whiteboard video on any machinery or concept of your choice, do let us know in the comments below.